Good morning, ROOTCON. So everyone is awake, right? I have seen most of you yesterday here at the parties, so it's customary to ask. He has already introduced us. We know we are here for a talk of hunting threats with Wireshark plugins, right? Uh, Again, I have this slide, right? So I have to do something with it. So my name is Nishant. I work for Pentester Academy and Attack Defense. Before that, before moving to core security, I was working with another firm. I was a firmware developer there. So I used to write code which runs on your Wi-Fi routers, Wi-Fi security systems. I have a master's degree in information security. I have been presenting my research at Black Hat, ASEAN, USA, Asia, DEFCON, China. We were here this year. We present at DEFCON, demo labs, workshops. I conduct Wi-Fi masterclass at Black Hat USA. And we also conduct trainings in HITV and as I was mentioning, yesterday we were here conducting this training here first time for ROOTCON. So it's a pleasure to be here and let these guys introduce themselves.
Hello ROOTCON, my name is Justin. I've been working as a security researcher at Pentester Academy for more than a year now. And my work has been published at Black Hat USA, Asia, ASEAN, DEFCON, China, USA, demo labs. And recently I also presented a research talk at DEFCON China. And now here I have to present a talk at ROOTCON.
Good morning everyone, I am Shivam Partner and I am a security researcher at Pentester Academy and my field of interest includes forensics, malware analysis, virtual pen testing, reverse engineering, etc.
So I think this view looks better, right? Otherwise the slide is actually going out of the view. So, yeah, one more modification that I can make is try to hide this. Yep. Yep. So some cool logos, because logos are cool, stickers are cool. This is what we do. Pentester.com is the main thing that we run. Attack defense is our next generation cyber range that you can use online. We are in the vendor area, so I'll not take more time here. If you're more interested about knowing what we do, how we can have your company as a whole, or you as Pentester, please visit us there. So, what the talk is about, we will discuss what Wireshark is, what Wireshark plugins are, and how you can actually write plugins to extend the functionality of Wireshark to do those things which Wireshark was never designed to, right? So, by definition, so what we will do now is we will first talk about motivation, why we did this, a little bit introduction about the plugins, and then what all things you can do. That's very important, right? How to do and what to do and why to do, right? Three questions. So, your Wireshark is actually for micro analysis, but when you are talking about detecting attacks, when you are talking about threat detection from your network traffic, right? Macro analysis is something that is needed. So when I say macro analysis, it means you have a lot of packets, but to find out the attack, you have to correlate between them, right? So network traffic analysis is something that it is useful for red team, blue team, even your developers use that. Because if you can see the traffic, if you can see what is really happening inside it, you don't even have to touch the machine which is sending it in some cases. So if you leverage it properly, you can actually do multiple things by using traffic analysis, right? So we will see how we can handle the customer and proprietary protocols, how we can do it on scale on your machine. When you move to cloud, there are multiple providers, multiple vendors that can do this for you. But the main logic here is to extend Wireshark. Now, also, just a show of hands, how many of you have heard of Wireshark? Okay, so those who don't know, Wireshark is a really good tool when you want to do network traffic analysis. You can open your network capture in that, you can go through packet to packet, and you can exactly pinpoint what is happening in one of the packets or you can literally see all the things that are going on your system through the packet analysis. So Wireshark, why do you choose Wireshark? Because it is used by most of the world people, and I think I will not even hesitate to say that 100% or 99.8% people in network traffic analysis area use Wireshark. So that's the reason why we thought, let's plug those gaps which are there. Wireshark on its is an awesome tool. It's been around for quite a long now, but it is designed to do microanalysis. It allows you to look into packets one by one. But the thing is, when you talk about detection of attacks, as I was explaining, right, macro is needed. So that's what we are plugging in. Your plugins can be written in your Lua scripts or your C language, right? Now, C language is something that is not very easy to grasp, especially if you are not a programmer full time. It is a little bit, pain to write it and then to compile it and to do everything. So what we did instead, we went for Lua language. Lua is just like the Python, right? It is very easy to write. You don't need to compile it. It runs on all kind of operating systems that you have, just like your Python. That's why we chose Lua. We went with Wireshark because Wireshark already does it really well. If you can build a plugin for it, it will automatically take care of all the parallel processing, all the background things for you. The Lua, again, easy to use, plug and play, no compilation needed, user friendly. And these are the type of plugins. So I'll let my colleague explain you about the type of plugins.
Okay, so Wireshark has the plugins in Wireshark can be classified as dissectors and listener tabs. So the dissectors can further be classified as chain dissectors, post dissectors, and heuristic dissectors. The listeners, they actually read the packet and provide you a summary of the information. So you can actually extract the summary. So you can do a macro analysis, an overview of the packet. For example, counting the number of HTTP packets in the complete TCAP. So here's a sample listener. So here you can see we have extracted the domain, the IP address, packets exchange, etc. Then comes the dissector. So what dissector does is like Wireshark shows you a view of the data which it is seeing, like decoding the protocols and showing you some fields like the IP address, port number, etc. So with dissectors we can actually enhance that view and add more of the information which we can extract from the packets. So here's a sample dissection flow. So in Wireshark there are dissectors for Ethernet, IP, TCP, HTTP, and we can even add our own custom dissectors and extract the information from the payload and display it in the views. So here's a sample dissector before, like it's a before view. We have not applied our dissector. So it looks like this, like normal Wireshark view. And after we have applied our dissector, as you can see in the yellow, hello world. So this is the dissector which we have applied. And it is showing it as a different field. So heuristic dissectors. So it's used to identify a protocol. There might be some instances where Wireshark is not able to identify what protocol it is because it might be running on a different port. For example, the DNS service runs on port 53. But if we are running it on say a different port like 8089, Wireshark might not be able to detect it and therefore it won't be able to decode it. So in that case, we can use the heuristic dissectors to actually extract some pattern and let the view know that okay, it is DNS traffic. So I'm going to show you an example here. So here's a sample dissection flow. Here Wireshark is able to know with TCP that okay what's going on, but after that we are using a custom heuristic dissector, my HTTP, which will actually decode the packets because it's running on a non-standard port. So I'll show you an example of a DNS heuristic dissector now. So here you can see the DNS traffic is shown as UDP. The destination code is 8089 and Wireshark is not able to decode it, right? So now we'll use a custom heuristic dissector and we'll show that how we are able to detect it. And for using that, so here you can see the protocol field is showing my DNS and we have used the heuristic dissector and we are able to detect it now. So instead of showing UDP, we are actually showing it's the DNS packet. So now my colleague will explain that what all can be done with the information that now we know.
Answering that question, we can perform macro analysis, we can modify traffic, we can detect different type of attack, as well as we can detect which tools were used to perform a specific attack. So in So when it comes to macro analysis, analyzing a single packet might not reveal much information, so we have to look at many packets collectively. So we have created simple plugins for HTTP, HTTPS, and Wi-Fi protocol. So for example, if we are told that an attacker is on the network and is downloading certain types of file, and we are provided with the network traffic, and we have to identify what files were downloaded. So what happens in this plugin is it analyzes the request and it identifies the URL, which is, as you can see, the images /I, that one, and from the response, it obtains what type of data was transferred. So the content type is obtained from the response, as well as the content name is obtained from the response. The next plugin comes, we can analyze the GET request. So where this can be useful. So for example, if a user is logging into a web application over HTTP and the HTTP form method is GET. So what this plugin will do, it will display the path as well as the parameter. So if the login page is submitted over GET, the parameters, the username and password will appear in the GET request. And this will display the parameters which were sent over the GET request. We can repeat the same thing with POST requests as well. Next, we'll take a look at HTTPS. So in case of TLS packets, we can only identify an IP address. We will not be able to retrieve information such as what parameter was passed. But is that all? Is the IP address all we can get from TLS packets? No. So provided if we have the entire capture, which contains the DNS request as well, from the DNS packet, we can use the IP address, and from the DNS packet, we can identify which was the domain name to which the request was being sent. Next, we have Wi-Fi based plugins. So in this plugin, as you can see, a lot of information is displayed as well as the security information is displayed. One of the access point has low encryption. So by default, Linux and Windows only show certain number of SSIDs, right? So in case if we are around like 100 to 100 access point and we have to identify which access point is open, this can be very helpful. And let's say we are an evil attacker, right? And we are sitting in a cafeteria and we just for fun we want to don't let other people connect to an internet, right? So as you can see in this, the data count here is 1100, which is an access point is transmitting data. From this information, we can identify the DSS ID and then perform the authentication attack, which will prevent anyone from transferring any data. Next comes modifying traffic to retrieve important information. In this case, we'll take a look at SRTP traffic. So when it comes to VoIP, RTP as well as SIP packets are very important. The SIP packets are used to establish the VoIP call, and the RTP packets act as a media carrier. Now, if RTP as well as SIP packets are unencrypted, Wireshark has a very beautiful feature which allows us to view the flow sequence, that is how the SIP packets are exchanged to set up the call. And Wireshark also has a feature to reconstruct the calls from the RTP stream. So as you can see, if you are an eavesdropper and somehow we have obtained the network traffic, we can hear what people are conversing from the RTP streams. So to prevent that, what we can do is have a configuration where SRTP is used instead of RTP. But an issue with using SIP packet with SRTP is that the encryption key which is used to encrypt the RTP stream are sent in the SIP packet. So if you have the entire capture, you can obtain the encryption key from the SIP packet and then decrypt the SRTP stream. So this is a SRTP stream, so if you try to play this, you'll only hear noise. So what we did, we wrote a simple plugin which will take the keys from the SIP packets and decrypt the SRTP streams. So to enable the plugin, all you have to do is navigate to preferences and select a checkbox. And what this will do is whenever the SIP packet, whenever there are for the SRTP packets, there are corresponding SIP packets, it will automatically take the keys and perform the decryption and provide us with the RTP stream. So finally, the decrypted stream will look like this. And now Wireshark does not have a very good audio player because Wireshark is a microanalysis tool, right? It's not a media player. So what we did was we created a plugin which will export all of the audio streams into audio file. And it's very easy to use. All you have to do is specify the path as well as the file name. And just click a button and it will dump all of the streams in form of WAV files. Next, we'll take a look at attack detection.
So, just to summarize what we saw till now, we looked at what kind of plugins are there, how you create those plugins, and what are the views. And just just to make it again very simple, you are either an attacker or you are a defender. You have network traffic. This is the problem that we are trying to solve, right? You only have your laptop with you. You only have Wireshark installed in it. You have some way to capture the packets. If it is Wi-Fi, you have a card with monitor mode on it. You have a network tagged to a physical network so that you can take the traffic out. Now, first problem is solved. You have the traffic, right? Now, second problem is what you can do with this traffic. When we say threat hunting using network traffic analysis, we are looking for attacks. We are looking for attack traffic. We are looking for anomaly. But even if you just want to see what is happening, what the guy is doing, you can actually do that with traffic analysis. So suppose on airport, right? You go to airport Wi-Fi is mostly open, right? You connect to that, you are now doing some browsing, you are downloading some files. Everyone knows that open Wi-Fi is not a good idea. But what's the reason behind that? One reason is an attacker can come, he can launch his own access point, you can fall for that, you can connect to him. Now your traffic is going through him, right? And he can launch multiple of MIDM attacks, man-in-the-middle attacks, and he can actually take over your computer by doing that. Because he can inject payloads in your traffic. There are hooks that you can put, you can backput the binaries that the guy is downloading, all of that is offensive side. But even if he is just using it, you don't want to actually attack him, by taking the traffic capture, you can find a lot of information about him. Now the thing is, it can be done, but if you are talking about 100 packets and 1000 packets, it can be done manually using your Wireshark. You can go packet to packet and you can see this. Think about it, you are at the airport, it's a busy airport, now you are not going to see 100 or 1000 packets. You are going to see 100, 1000 or million packets. Now the problem is, you want to do it quickly. One way to do it, you go there, you buy a third-party tool from someone, and then you use that. But that costs money, right? And if your company buys it for you, it will be installed on company laptop. You cannot do it on runtime. That's why Wireshark is free, it's open, it runs on all the major operating systems that you have, any kind of Linux, any kind of Windows, any kind of Mac, it runs. You can literally take any computer right now, you can download it free from internet, and you can download all plugins, you can start doing it. And it doesn't stop there. If you're using third-party tools, you have limitations. You cannot go beyond that. With plugins, you can modify it, you can do whatever you like. So what he was showing you was analysis of HTTP. So you have 100 and 1000 packets of HTTP. You want to build a profile of the guy. What he was trying to do, what kind of websites he's looking at, right? If he is shopping something from, some e-commerce website or something else. If he is using HTTPS, obviously you won't be able to look inside the packets, but still, from the metadata, we can tell which sites he is using. How? Because we are correlating the DNS packets with your HTTP packets. And that is what macro analysis is. So, this is how threat hunting is. Threat hunting is a buzzword. It's nothing but you look for attacks, you look for attack tools. That's all it is. And that is what we are now taking forward to the attack tools. So, you know about Wi-Fi attacks, right? Beacon flood. You all are using Wi-Fi. Suppose for some reason, I don't have anything better to do. I want to disrupt your Wi-Fi. There are multiple attacks that we can do. I can make sure that when you pull out your device, you see 1000 networks. It's very easy. I can buy a $5 device. I can make sure no one in this range can use Wi-Fi. It's that easy. Now detecting it with third-party enterprise grade tools, yes, it is easy. But you don't have those on your disposal, right? You want to see what is happening. So there you can actually turn on your Wireshark, take a quick capture. It will show you that all of these SSIDs are there. And it will tell you from the channels and the beacon send that it is fake. So you can actually tell the difference. Similarly, if someone is sending your packets, right? I am not sure why someone is not doing it there. I see it every year at DEFCON, even in Black Hat people do it. They get caught, but they do it for some reason. So, beyond and distribution packets, it can actually make sure that no one can actually connect to the network, network and access the internet. So all of that you can detect with Wireshark. You can see if someone is trying to brute force your network, if someone is trying to connect again and again and trying to capture the handset for tracking. You can try to see if someone is operating an event win. Event win is a Wi-Fi access point with the same name, with the same characteristics, so that you connect to that and again, boom, right? MIDN. There is a full-blown list of attacks that can happen on it. You can look for it. MIDN is one of the categories that people ignore a lot. Similarly, if you talk about other protocols, it's not just Wi-Fi. It can be applied to any protocol. It can be even applied to the proprietary protocol that your company might be using. Right? So that's the thing. It is extensible, it is open, and that's why we love it. We gave a talk on it on DEFCON China. We presented a tool, and that tool is freely available. It's open source. I'll show you the link in the end. You can detect MIDM attacks, and sometimes when hackers are doing things, most of the times no one actually sits and builds their own tools. They are using some of the free tools that are out there. Now, if some way, if you can tell that a attacker is trying to target you, see, so there is this very famous quote about deception, right? If you read book Art of War, they say that deception is the main thing if you want to win a war. And it is a war, make no mistake about it. It is a war between you and the bad guy. Or if you are the bad guy, then you are the good guy. It doesn't matter, it's a war. So, if you can detect him early, you can take mitigation steps. And that is where, if you can find out that someone is operating airbase, so in this case, airbase is actually a tool which is used to create fake unlocked Wi-Fi networks. So if you can, by just looking at traffic, and tell that it is airbase, you know someone is trying to get you. And then you can take preventive steps, you can take reactive steps, right? You can do something about it. But if you don't know, you just wait. And by we love this line, by game theory, we know that the attacker has to succeed once. But as a defender, you have to defend it all the time. Right? So knowing is important. So we can do airbase detection for any kind of network that the guy can create. So a quick demo video. So in this demo video, what we are showing you is how our plugin can actually decrypt your SITP traffic. So play this, I think you have to display. Yeah. So as you can observe here, this is your VoIP traffic capture. You have SIP packets. SIP is for signaling. Then you have your RTP stream, which is encrypted right now, right? This is what we told you. And we can see the RTP stream here. If you try to plot it, because Wireshark has this feature, it can actually reconstruct packets into streams. It looks like this because it is encrypted using AES. And AES is really good at its job. It's pretty random. You will just hear the ability to play this, right? Now, what we did, we created these plugins because the previous variable open source tools were really hard to use. They were platform dependent. So created this. You just take this and it automatically goes and decrypt all the packets. How many lines of code it took? Less than 150. That's all. Everything else, Wireshark is doing. And you can actually read this code, it's not even file. You just put it there and it automatically runs. There you go. Oh,
Alright. So, this is an announcement while we're printing their chalice. ROOTCON. Cheers, guys. So that's it now. There are more tools now in the hacking village, so feel free to drop by. Also, Hardware Hacking Village has a mini CDF. If you guys want to join, please drop by. More drinks?
So yeah,
ROOTCON.
Drink. You're okay? You can have one. You can have one.
so it is his first time drinking.
Welcome to the village.
He is part of the cult now.
Wonderful.
So yeah.
At least you'll be drinking more.
There's also previous speaker before.
Oh, it's a previous speaker who was first time drinking here, so.
So yeah, this is how easy it is. You write some line of code, it does all the work for you. Go back to the slide, please. So these are the tools that are out there. They're open source. You can read the code, you can modify the code, you can extend the functionality from what we have done. You can modify them for your use. It's actionable thing. It's not just talk. That's what we love about it. You go there, you try it out, and you'll find how easy it is. It's not difficult at all. Similarly, we also have this one for VoIP analysis. This is the one which does decryption. It can export the call so that you can take it out, you can play it in MP3, or you can analyze it in some other tool. All of that you can do. It is open source. It uses GPL because Wireshark is GPL. So you just search for Pentester Academy on GitHub, you will find these tools there. How to install them? Just download them. All the instructions are there on GitHub. Just to make it, more simpler, you just go to your Wireshark, you go to help about Wireshark, you go to folders. It will show you the plugins folder. Just copy the files, you paste them in plugins folder, and you're done. That's all it means. So, with that, I conclude this talk. We are here for the questions. If you have any questions, we will take those now.
Yes, question, sir.
Yes, thank you for your talk. It's interesting and your tools. I definitely will try it. But I have a question that when we try to use Wireshark in maybe a company in large scale situation, for my past experience, it will be very slow to analyze a large amount of a package, maybe over 1 gigabyte package. In that case, I even cannot open it by Wireshark. So the first question is, how can I address the performance problem of Wireshark? And the second part is that, as I analyze, maybe I want to do some automated things, maybe automated to collect some information and send out to the platform. For this, do you have any recommendation that I can automate the Wireshark script? Okay.
It's a really good question. I will just repeat it so that you know what exactly the problem is. It's a real world problem. We all face it. Thing is, he's telling that for even hundreds of thousands of packets, when you are there, when you are in 6 digits, it works. Now, if you have more powerful machine, it might work for more packets, right? But that is dependent on the machine. So he's asking that what we will do when we have millions and millions of packets to process, and if you want to do the same thing in that. So, thing is, Wireshark was created for this scale only, the one that we use, right? So the only way right now is to upgrade your machine, but there are other ways to do traffic analysis. And for that, what now people are doing, they are using Elasticsearch. So you know ELK, right? So it's Elasticsearch, log test Kavana. It's a very, very, very popular thing. People use it for log analysis. If you have a packet beat is a thing that they provided with their thing. It's available on their website for free. You can actually take that. You can take all the packets and you push them into Elasticsearch. Now Elasticsearch is built for scalability. So I myself has actually tried it. So one of our customers had
about exactly. So will you try to micro your party into Elasticsearch version?
So, thing with Elasticsearch is it is so easy to set up, and the thing that we are doing here, right? It is even better in that because your Elasticsearch, from the name itself, you get that it's a search. So if you know what to look for, and it can be macro analysis. So we have done things on that. So the way of doing things is different in that. But then you're talking about scale, right? Now you can literally go ahead and find these threads within millions of packets. So that's the way I will recommend. Because Wireshark, even if you upgrade your machine, there's only so much that it can do. It's not built for billion and billion of packets. Any more questions?
More questions?
Do you think it's possible with Wireshark plugins eventually help us with ARP plots?
Very good question. You download the PA toolkit, we have that. It will show you all the ARPs, it will create a table for you in which you can see the ARP table, right? That your machine sees. Because all the packets that ARP is sending, if you correlate them, you can actually find the IP address and ARP mapping, right? So from that you can even detect the ARP is something like that. And that's how we were doing the MIP thing. Because if you are seeing two IPs with same MAC, you would explain it. It is not possible. MAC is given by manufacturer. It is unique, universal. Any more questions?
Once, twice. More questions, guys? All good?
So thank you, ROOTCON. Thank you, Boons. Thank you for having us here. We really enjoyed the view and the space.
Thank you, guys.